Carbon is one of the most important elements on Earth. But before we get into it, let's go over some terms. So carbon hates to be by itself. It's normally found bonded to another molecule, such as hydrogen or oxygen. When it's linked with a hydrogen atom, this is what we call an organic compound, which is often found in living organisms. Otherwise, carbon not involved with living organisms and bonded with atoms such as oxygen, calcium, or nitrogen is usually called inorganic. Now, let's talk about the carbon cycle. The short-term carbon cycle is characterized mainly by its timescale, which ranges from months to years. This cycle sees the conversion of inorganic carbon to organic carbon by photosynthesis. Photosynthesis takes the atmospheric carbon dioxide, water, and sunlight and turns it into organic matter and oxygen for plants and animals to use for respiration. The process of respiration takes in oxygen and sugar and releases carbon dioxide and water back into the environment. In environments where there is not a steady source of oxygen, some bacteria decompose organic matter through an anaerobic process known as methanogenesis. This releases carbon dioxide and methane back into the environment as well. In the marine environment, phytoplankton consume carbon dioxide and produce oxygen through photosynthesis just like plants on land. Zooplankton are organisms which consume the oxygen and phytoplankton and produce carbon dioxide as a result. While most of the organic material is consumed by the upper layers of the ocean, some of the organic matter falls to the seafloor. In the deep ocean, organisms use processes such as decomposition and respiration to turn the matter back into carbon dioxide and water. This nutrients is brought back to the surface by upwelling and the cycle continues. This cycle is called the biological pump. The long-term cycle, on the other hand, is in timescales ranging from thousands to up to 1,000,000 years. This cycle can be broken down into the organic and inorganic cycles. The organic cycle begins with the burial of carbon in sedimentary rocks. The movement of sediments to seafloors caused previously deposited materials to be further buried under newer sediment. Over time, the sediments are lithified and trapped in sedimentary rock. Eventually, by exposure to the atmospheric oxygen or groundwaters containing oxygen, a chemical reaction with the organic sedimentary rock occurs, releasing carbon dioxide back into the environment. The inorganic cycle begins with atmospheric carbon dioxide dissolving into rain and surface water to make carbonic acid. Meanwhile, carbonate as well as silicate rocks brought to the surface by plate tectonics are converted from H2CO3 to HCO3 by chemical weathering. These ions are moved into the ocean through runoff and downwelling. Death of marine organisms which form skeletons and shells create calcium carbonate and form sediments on the ocean floor. Lastly, this calcium carbonate is added to the oceanic tectonic plates and turned into silicate rocks, where it is eventually uplifted after millions of years and exposed to Earth's atmosphere, thus repeating the cycle.